Welcome to this unit of chemistry. In this unit, we'll be focused primarily on the chemical bond and the structures that we find when we connect atoms together. In the last unit, we focused on the electrons and their positions and energies inside of the atom. Now we're focused on how are those electrons being used to unite two atoms together in a chemical bond. When we think about most matter on the surface of the planet Earth, most matter is not found in its pure elemental form. We have rods of iron, perhaps we have bars of gold. We've purified gases and compressed them and put them in tanks like helium to fill up balloons and for other purposes. But when we think about matter, most of the matter that we find on the planet is composed of compounds. So compounds are material that we have different types of atoms coming together and being connected together by these chemical bonds. Again, these electrons are critically important for the chemical bonds that we see, and different types of chemical bonds are produced and are resulting from the interaction of electrons between the two atoms. For example, in ionic bonds, we can think of one atom giving up an electron, losing it completely to another atom gaining that electron completely. And in that way, these two atoms now become ions. One has lost a negative charge because electrons are negatively charged. One has gained that electron, which is now negatively charged. And we have this positive-negative attraction that forms an ionic bond. In contrast, we have covalent bonds where we have a sharing of electrons. And we see these two atoms coming together, and one atom allows another atom to see those electrons. And as a result of that interaction of electrons between those atoms come together and form a bond. Again, most compounds that we see on the planet are not composed necessarily of just one atom or one atom type. We actually are seeing chemical bonds holding atoms together to form different compounds. Some atoms can form multiple bonds to multiple different other atoms. For example, carbon. We are all carbon-based life forms. We have carbon at the center of most of our molecules. And those carbons can form up to 4 bonds to 4 other atoms. And as a result of those electrons being present in those bonds, and because they are negatively charged, we know that those negative charges repel each other. And when we put a carbon atom and we put these other atoms around that, and we have electrons that are stabilizing those bonding interactions, they want to spread out to maximize their separation and minimize their repulsion. And as a result of that, we get three-dimensional structures. We get molecules that are what we call tetrahedral, where we have separated those 4 atoms bonded to that carbon kind of as far away from possible around that carbon in 360-degree space around that atom. We will look at the geometries. We'll apply geometries and geometric words to those, like tetrahedral or pyramidal. And in that way, we can begin describing not only the bond, but also the structure of these molecules that we see in life. Some of the tips that we have for this particular unit are that you definitely should use some of the practice worksheets that I'll provide. That will help you identify both ionic compounds and molecular compounds, but also be able to help you walk through looking at molecules and looking at the structures and defining the actual geometry for each of these structures that we see in these simple molecules or simpler polyatomic ions. So again, the main theme for this particular unit is chemical bonding and molecular structure, and these two properties go hand in hand as we look forward in this unit.